Hey, Kenneth, I'm going to work that problem for you that you were talking about. Um, these are the kind of problems that really makes me wish that we were having class together to talk about this stuff. But anyway, I'm gonna make a video and send it to you, and I'm just gonna work it. Make sure you understand it. Okay. So here's the equation that you need. It's actually equation 3.5, and with this iPad, I'm trying to get used to doing a little better. My fours look like nines, but anyway, so I got it tilted. Let me change, go back to where we were. Sorry about that. And so hold on just a second. Let me fix this. Yeah, so here's the equation. And first off, the first thing I see is that that test question was wrong. It said that the inferred absolute temperature of copper was 243.5. It's 234.5. But anyway, it would have worked out the same regardless, but that's the actual number it should be. It should be 234.5. And so here's the equation. So really what you're doing is a proportion, and we're assuming that there's this linear relationship with increase in temperature with increase of resistance. And so we can sort of follow that curve that you see in figure 311 in your textbook. In actuality, it's not quite linear, but like he says in the text, we assume that it's linear, and that allows us to use a proportion like this. So what I'm going to do is I'm given three of the things, and I'm going to try to figure out the fourth, basically. So as I work this problem, my T1 would be 25 degrees C, and my resistance would be 10 ohms. So I'm going to say 234.5 plus T1, which is 25 degrees C, over 10 ohms, which of course is this. And then that is equal to 234.5 plus T2, which is 200 degrees. And what we're trying to solve for is R2. Okay. So at this point, why don't we go ahead and get some numbers in this, and then we'll solve this for R2, and that should give us the right answer that we're looking for. Okay, so I added the steps in here, and then, went back and fixed this like we were talking about. So, we get to this point here with 234.5 plus 25 divided by 10, filling in the blanks here, so there's that step. And then solving for R2, I end up with this. Basically, multiply both sides by R2, divide both sides by 259.5 over 10, and that's where I get this. And then I go ahead and solve that. In my calculator, I had it set up to display 4 decimal places. The answer blank says round to the thousandths place. So the correct answer for this would be 16.744. Okay, so that's the solution to that. Let me know if that helps you, or if you've got additional questions.